Welcome to the new video tutorial on IoT demo using Python and Bottle framework. In this tutorial, I am going to show you how to read sensor data from mobile phone and plot that on browser using Bottle framework. So let's start. First of all, I need to connect both my system and my mobile phone to the same Wi-Fi network, and then I need to install one application in my mobile phone to read sensor data from mobile into the PC. So there are many applications available, but I am using sensordroid application. I already installed sensordroid application in my mobile phone, and in Python there is a library called sensordroid. So with these two, the application as well as the sensordroid library, it is easier to connect both the mobile phone and system to read the sensor data. So in the latest mobiles, all the sensors are inbuilt available, and for this tutorial purpose I am using Accelerator sensor. So let's move on to the code. First of all, I need to install some libraries like CSV, datetime as well as sensordroid. Then I am creating an empty CSV file here to store all the data which is read from the mobile, that is sensor data, into this CSV file. And I am using write mode here because I can use append mode also, but I want to create a real-time plot here. So if I use write mode, the data whatever is loaded into the CSV file previously will be deleted, and every time when I run this program, new data will be loaded into the CSV file. Otherwise, if I use append mode, the data will not be erased, and it will not be possible to create a real-time plot. So that's why I am using write mode. And next I am creating header, that is the column names. So this is the time, this indicates the real time, that is a local time, and x co, y co and z co are the x, y and z coordinates. These are because accelerator values can be read in 3 coordinates. So I used x, y and z coordinates as columns. Then I am using dict writer here. Using that, I am going to write this header into the CSV file, and write header will write the header into the CSV file. So the file is ready. Next comes reading the sensor data. So for that purpose, I am creating a function called read sensor data here. So actually we can find any other available devices nearby the sensor, but for the simplicity and for this tutorial purpose, I am directly connecting this program to my mobile IP address. You can get to know this IP address when you go to settings, and you can search for IP address in your mobile. And this is the client function which I am using from sensordroid to connect to my mobile IP address. Next comes the client.sensors received, and here I am using port is equal to 0. This is a default port. So whatever the sensors it detects, it will be connected using this port, and that will be done using this connect sensors and sensors received functions of the client. Then whatever the sensors it gets detected, those will be connected using client.connect, and then it should start discovery. It means it should start reading the sensor data. Then I wanted to know the status of connection to the client, that is whether the device is connected or not. So for that I'm using if condition here. If the client dot connected, if this is true, then it should print connected to the IP address, that is the IP address of the client, that is my mobile address. Next, otherwise it should print disconnected. Next, I am using while loop here. This is because I want to run this program forever. Like I want to read the sensor data infinite times until unless I stop the execution of this program. So for that purpose I am using while loop. So while true, it should execute this code. So here the data will be client dot data current dot acceleration. So here you can select what type of sensor you want to read. So for example, you can see here light, temperature, humidity, all these sensors are listed here. You can use any of the sensor and read data from that. And I'm using this acceleration dot values dot as string to get the sensor values. Then client dot sensor sample rate. This is because to delay the data reading, that is this indicates the delay, that is the time gap between each and every reading. And as I told you before, the acceleration values will be in 3 coordinates x, y and z. I am going to split that data into 3 variables, y1, y2 and y3. And to get the local time, I am using datetime.now.strftime, and the format will be hours, minutes and seconds, and time now will be the local time. And finally I want to write all these sensor data into a CSV file along with the local time. So for that purpose I am creating a dictionary here, and to the exact column name I will be going to write the data, that is to the time column I am going to assign time now, that is the local time, and x co, y co, z co are the 3 columns, and to those columns I am going to assign the sensor data values, that is y1, y2 and y3. You can observe here 0 colon 5. This indicates that the data which is read from the sensor will be in a decimal point, and that will be very long also. So in order to plot the real time graph properly, I am just considering only limited number of decimal points here. So for example, if the data is like 0 point something, it will be very difficult for plotting the real time graph. So I just want to consider only limited number of decimal points. So if I use 0 to 5, it will just print 3 decimal points after this 0. So that's why I'm using this 0 colon 5 here. And next is I need to call this function in order to make it work. So if we want to see the data which is read from the accelerator directly, we can use print of data. So let's run this. See, as I disconnected, as I am not using that sensordroid application, it is telling me the device is disconnected. Now when I open the sensordroid application in my mobile, it will just connected and read the sensor data, and the values will be changed according to the acceleration orientation of my mobile. You can observe that, and all these values will be automatically written into the CSV file. Let's see. You can observe this is the local time, and this is the X co, Y co, and Z co, that is X, Y, Z coordinates. So in this way you can read any sensor data from your mobile using sensordroid application. So next what I am going to do is I want to use all these sensor readings and plot them as a real-time plot, real-time graph. So for that purpose I need to write a Python code again, and this is that Python code, and I have written in this entire Python code in a template file, that is .tpl file. I'll tell you what is template file later. So for now I'll explain you how to write Python code inside a template file. So there are some rules to write Python code inside template file. Those are, we have to use percentile character to indicate any Python program inside this template file. So whenever a line is starting with this percentile character, it will be considered that the line is the Python code. And if you want to define any function, or if you want to use any loop or any if condition, that should be nested inside this starting bracket, that is less than symbol, and the percentile character, and at the end of that if statement or for loop or the function, we have to close this using closing bracket, that is greater than symbol followed by percentile character. And next, one more thing is, if we want to define any loop or any function or any if statement, that should be completed with an end keyword, otherwise the program will not be worked. So these are the basic rules to remember while writing Python code inside a template file. So let me explain you the code. So for plotting this data, sensor data as a line plot, as a real-time plot, I need to install some libraries like time, pandas, matplotlib.pyplot, as well as func animation. So this func animation function is very important for plotting real-time graph. Next, I am defining a function called animate, and inside this function I am going to read the sensor data, that is whatever the data written into the CSV file which is read from the sensor of mobile phone, that will be continuously read into this program using pandas, that is pd.readcsv function. And as you can observe here, time, X co, Y co, as well as Z co columns are there. So to read those columns, I am going to assign those column values into new separate variables. So I am going to assign time to the X values variable, and similarly X, Y, Z coordinate values to Y1, Y2 and Y3 variables. And here comes CLA. CLA indicates that it will clear the current access. So for real-time plot, this function is very helpful. And next comes plt.plot. So in matplotlib, for plotting any line on the graph, you have to use plt.plot, and you have to define the x and y axis values. So for the x axis values, it will be x values, that is time, because accelerated data will be plotted as time versus acceleration. So on the x axis I am considering x values, and on the y axis, that is for the x coordinate, I am just plotting 3 coordinate values in 3 different lines. So on the y axis it will be y1 values, and I am defining the line width as 1. Then I want to define each and every coordinate values as a separate line. So I just want to differentiate each and every line with their colors. So for the x coordinate orange, and for the y coordinate blue, and for the z coordinate I am using brown color. And I am mentioning label also for the each and every line. So for plotting x coordinate values, I am using the label as x coord, and similarly for y axis y coord, and for z axis z coord. Next comes labeling. So labeling is very important one while plotting any graph. So on the x axis I am going to label it as time, and on the y axis I am going to label as acceleration, and the title comes here is accelerator sensor readings. And I am using the legend also. Legend will be helpful to understand which line of the graph is related to which coordinate. So that will be that data it will get from the plt.plot, that is label, from the label parameter. And next comes the plt.gcf.auto format extend. This will helpful for auto formatting the alignment of labels on the x-axis. As I am telling that it is a real-time plot, I need to give labels as local time, that is hours, minutes and seconds. So if I align those values in a horizontal manner, those values will be getting clumsy and getting overlapped on each other. So to avoid that clumsiness, to plot the graph very neatly, I am using this auto format extend, and this will automatically align that x-axis labels. Next, tight layout. It will automatically adjust the plot around its borders. Then I am using time.sleep. This is because as the sensor is pushing the values, and the program is able to read values every second. The value is getting updated every second on the graph. So we are not able to understand the time values clearly. So I introduced 1 second delay, that is time.sleep of 1, to make the graph little bit slow, that is to update the graph little bit slow, so that we can clearly observe the time values and how the data is getting updated on the graph. Then I am closing using the end keyword. I am closing this function. Next, I need to call this animate function. So as I told you before, func animation function is really helpful for plotting real-time graph. So in that I am going to call this animate function, and I am going to use the interval. Interval indicates that the time gap between the sensor readings, that is after how many seconds the data should be updated onto the graph. That will be the interval. And the plt.tight layout I am using again, and And finally, I'm using plt.show function to display the graph. Now the Python code is completed and I need to plot this on the browser. So in order to plot this on the browser, I need to use Bottle framework. So let me tell you what is Bottle. So Bottle is a lightweight web framework. It will be useful for deploying simple Python applications onto the browser. So from Bottle, I'm going to import the run, Bottle and template. So first of all, I'm using a variable called app, that is the application, Bottle application. So as it is a Bottle application, I'm using this function Bottle and assigning it to the app variable. And next, from this Bottle app, I am using root decorator. So what this root decorator will do is, it will link the function defined under this root decorator to the URL provided inside it. So simply I just used only forward slash without any URL name. You can create your own URL name like hello or something like that. You can simply use that. And to understand Bottle easily, I'll show you a simple example of hello world. So I want to print hello world text on the browser using this Bottle framework. So for that I am using yield statement here. Actually we can use print statement for printing any string, but if we want to print anything on the browser, we have to use yield, because print statement will be working only on the local machines but not in the browsers. So I'm using this yield statement with hello world. And finally I'm using this run function, and inside this app will be the app variable, that is Bottle, and the default host will be localhost. So I'm using that only, and the default port will be 8080. And here debug and reloader are very helpful. If we made any changes inside the Python program, inside this body of the function, and we need not to rerun the Python program again and again. You can simply go to the browser and refresh the page, and all the changes made inside this function will be affected on the browser. So that is the reason we can use debug and reloader with the boolean value true. Now let's run this. So this will be redirected to the port. So you can observe hello world. You can see hello world here. So in this way you can use Bottle application. And for this tutorial I am going to use a template function from Bottle application so that I can execute any Python code inside this template. So now template is the function inside Bottle, and this will just read any HTML or template files and execute it on the browser. So it can accept any HTML like .html files, or it will accept .tpl files. So now let's run our program. So actually this CSV data is read from the sensor, that is from this program. So I need to run both the Python programs simultaneously. So let's do that. Yes, you can observe that all the x, y and z coordinate values are displaying here. And this is the legend indicating x, y and z coordinates. So in this way, you can read any sensor data from your mobile phone using sensordroid application and plot that on browser. So let's stop this. And I would like to say one more thing, that is, you can get one doubt that without storing the sensor data into CSV file, uh, why can't we plot them directly? So actually I also tried that. If we directly plot the graph on the y-axis, the values will not be aligned properly. The graph will just move upward. The graph will be incrementing in an upward direction, the value irrespective of this values. So if we store all these values inside a CSV file and read data from that and plot the graph, then the values will be perfectly aligned on the y-axis and the graph will be perfectly plotted. You can get all these Python programs from my GitHub repository, which is mentioned in the description. Like this, you can read any sensor data, and thanks for watching.